Well, good evening, everyone. Thank you very much for coming along on what does look as though it's a little bit of a wet evening out there against what we've been promised, a little bit of sunshine today, but nevertheless we didn't get it. But thank you very much for coming along. If we can just have a few little announcements, could you please remember to sign the book and the log as you come in or as you go out, because it does give us a little bit of a remuneration from IOM3. Could you also be aware of where the fire escape is and just follow the signs? If the worst happens, follow the signs and that will lead you to safety. We haven't got a president's welcome tonight, but I'll stand in and do whatever welcome I can. And we'll look at what we had at the last meeting, which was a hydrogeologist, Joseph Cherry, giving us a talk on the hydrogeology of ground source drinking water, which was well attended. There were quite a number of questions there too. There weren't many apologies for absence, Brian Pickering and Stuart Porterhouse. Whereas tonight we have a few apologies again. I don't think Stuart's made it, Stuart Porterhouse has made it, he said he may do. But that's Paul Kelly also give us apologies, and Ron McNally. And it looks like Andrew is also going to be an apology tonight. Brian Pickering, I'll make a note of that. Brian Pickering. I haven't had an apology myself, although it may have come through the president, who hasn't informed us of anything at the moment. So it may come later or later in the evening, I don't know. Nonetheless, let's see, where were we? Yes, the minutes of the last meeting, as we say, which was the hydrogeology of ground source drinking water. Has everyone seen the minutes for that one? And if they have, could you please give me your vote and say, yeah, thank you very much. Seconded by anyone? Okay, Derek, thank you. I'll make a note of that too. Right, thank you very much. Well, just a few promotional little ideas here that we must remember that we are very, very closely allied with the IOM3. So I'd like to, make sure you're all fully aware that it would be very sensible if you want to advance your careers any further that you do join into IOM3, because they have so much more to offer in a lot of the spheres of operations these days. So we'll go for that. The other thing is we can now move on to the presentation for tonight, which is going to be Dr. Peter Wilkinson, who is the past president of the Institute of Fire Engineers, and he's going to give us a talk on fire engineering, an introduction to the profession and practice. Now, I'll just go back through my notes. Peter is a chartered engineer, a chartered scientist, and a registered fire risk assessor, with a passion for helping organizations understand and manage physical risks within the buildings they design, own, occupy, insure, or regulate. He is the founder and director of an independent fire and risk engineering practice, providing a wide range of high integrity, cost-effective services to both established buildings and new build projects. Peter is also a director and trustee of the Institution of Fire Engineers, that's the IFE, the International Organization for Fire Professionals, helping to promote the profession and register professional engineers with the Engineering Council. Receiving an engineering doctorate for investigations into resilient fire engineering building design, Peter has published numerous journal and conference papers, as well as having authored guidance documents for the profession. Peter would be a strong addition to any solution team, whether leading complex fire engineering projects, risk engineering, surveys, or fire risk assessment. I'm not going to go any further with describing exactly what Peter's going to talk about, because I'll leave it to him and he'll be much, much better at it than I am. So can I introduce you to Peter Wilkinson?
Fantastic. Thank you very much. It's great to have the opportunity to present to you today, and I'm really grateful for the invitation from the Mining Institute to hold this joint institutional lecture. I'm going to talk to you today I'm going to take a bit of a look back into the origins of fire engineering as a profession. I'm going to describe its development as it matures into an engineering profession. I'm going to introduce the Institution of Fire Engineers to you, and then consider some of those contemporary competence questions that are critically important to fire safety professionals. And unfortunately, the tragic events that occurred at Grenfell Tower in June 2017 and the subsequent public inquiry have revealed the shocking truth about competence, or rather the lack of it, right across the construction sector. So this lecture will explore what competence means for the fire safety professional and the wider built environment, and we'll also look at how that competence can be demonstrated to others in order to restore public confidence in what we do. But first, we need a definition. I'm sorry, technical man. Not those. Apologies to those watching online.
Right. It was working before, so let's close it down altogether. Sorry. It's on the drive.
Yes.
I'll cut this out on the...
This is why the YouTube's edited. Yeah.
This is your drive, is it?
No, maybe it's that one. Yes, right, so.
Just,
Do that.
that's it. And then just step through it.
Brilliant. Thank you very much. Right, sorry. So, I left us hanging on that. We need a definition. So what is fire engineering? Well, the Institution of Fire Engineers has a good definition, and you'd expect that. We're an institution full of fire engineers. And it's a broad subject area. So it's the application of scientific and engineering principles, rules, and expert judgment based on an understanding of the phenomena and the effects of fire, and the reaction and behaviour of people to fire to protect people, property and the environment from the destructive effects of fire. Okay. This is another definition. It's probably better, it's more comprehensive, and it makes sense. So it's that same bit at the beginning, but fire engineering, that measurement, that quantification of stuff, is that bottom bullet point, the evaluate analytically the optimum protective and preventative measures necessary to limit within prescribed levels the consequences of fire. That really gets to the heart of the engineering principles. There is another definition, and I prefer this one because it's really simple. Use of engineering principles for the achievement of fire safety. So the kind of fire engineering I'm talking about today is a performance-based way of meeting functional requirements that are set out in national building regulations. And in the UK, those functional requirements come from various bits of legislation. We have the Building Act, we have the Sustainable and Secure Buildings Act, and most recently, coming into force completely next April 2024, is the Building Safety Act, particularly for higher risk buildings. But the purposes of these regulations are listed here. You know, we've got health, safety, welfare of people in and around buildings. The legislation clearly has a life safety focus. Interestingly, you'll notice that protection of property or protection of business is not really mentioned in these purposes. Well, unless you argue that preventing buildings from burning down helps with sustainability, and that's probably a valid argument. So we'll just if we try and remember that legislation is trying to, quite rightly, is convincing us that fire safety is about life safety. But what about that little bit extra? We'll come on to that later. And those functional requirements for fire safety in building design are set out in building regulations. I just happen to have the building regulations of England and Wales here, and building standards in Scotland. And they're really quite simple goals, such as these that are listed in Schedule 1 requirements for fire safety. It's not always been this way, though. Statutory fire safety provision in the UK has evolved slowly over many centuries, and it's largely been driven by major disasters. In the 20th century, experiences of fires during the Second World War were incorporated into the post-war building studies on fire grading of buildings. And these were seen as landmark documents of their day, influencing the technical content of subsequent building regulations. And by the time further amendments were made in 1976, so that book on the right, the regulations comprised 307 pages, and they were highly prescriptive. These traditional prescriptive building regulation systems had procedures to oversee departures from a standard solution, but these seem to be cumbersome in nature. So, in England and Wales, such relaxations were at one time only granted by central government. And that was seen as quite a cumbersome and difficult system. So where has performance-based engineering come from? Well, it's been born out of the need for it. So as a result of large and rapid increase in innovative and diversified building design, including the expansion of air travel in the early 1970s, prescriptive regulations became demonstrably restrictive and inflexible. So by way of example, air travel required airports to start handling large numbers of people who were unfamiliar with their building, but they needed to be handled in a pleasant and efficient way. Designs based on prescriptive standards of the time simply couldn't cope with this new design requirement. So some engineers and scientists saw the possibility of applying scientific research directly to the design of individual buildings. And these were discussed at the time of the design of Stansted Airport, and that's what in the photo, designed by fire engineer Margaret Law, who is sadly no longer with us. So one important issue relating to this airport design was the need for large compartment volumes, not permitted under building regulations without obtaining that relaxation. So Margaret Law collected a range of data from experiments and surveys and fire statistics to demonstrate or to illustrate how various measures could compensate for that lack of fire-resisting construction, which is known as compartmentation. She created this cabin concept where smoke control is devised underneath this quite interesting roof design. And the commitment of the government of the day to deregulation and to reduce the burden on industry, phrases we hear quite a lot, led in 1985 to the introduction of new functional building regulations. So, in 1985, these set out the requirements for fire safety in buildings in functional statements, very simple statements that we've already touched on. And designers were now free to provide any solution that could be shown to the satisfaction of the enforcing authority to fulfill these functional requirements. And this timing coincided with the design and the construction of the first towers at Canary Wharf in this photo here. And whilst formal recognition and acceptance of the use of fire engineering had been given in England and Wales within that 1985 edition of the regulations and accompanying approved document B, there was no guidance given on how to use those principles. So pressure for guidance and a structure for the application of fire engineering to the design of buildings came from designers, and an initiative by British Standards Institution to provide a code of practice was begun. In 1989, a format and a list of contents was presented to BSI, and by the end of 1990, a small panel of fire safety engineers was formed to undertake a 3-year contract administered by BSI, which would culminate in a code of practice giving the framework for fire engineering design in buildings. The panel first met in 1991, and the draft code of practice was published as Draft for Development, DD 240, in 1997. 6 years, that's not bad for BSI. Now, DD 240 was described at the time as being the most important document produced in the UK in support of the use of these more fundamental approaches to fire safety design. And it provided the designer and the regulatory enforcement authorities with an overview of what was considered to be necessary. It was structured into subsystems, and importantly, it indicated that there were still gaps in knowledge and much still had to be achieved by engineering judgment. Since that publication, DD 240, the group within the British Standards Institution, FSH 24, is a technical committee. They remain responsible for the development of standards of fire engineering in buildings. And that committee draws representatives from a wide range of stakeholder organisations, as well as research bodies and teaching and practising fire engineers. So FSH 24 is the National Committee for Fire Engineering, and it mirrors much of the work that goes on in ISO committees around the world. And FSH 24 has been responsible for developing, from that draft for development, DD 240, the standard BS 7974. This document was first published in 2001. It's supported by 8 published documents, and each contain detailed guidance on different aspects of fire engineering, from background information to quantitative risk assessment. And a framework for the application of fire engineering is provided in the standard, and it's really, the essence of it is defined here. And this flowchart is what you see in the start of the document. And essentially it comprises, you can boil it down to three stages. That's a qualitative design review. That's where the scope and the objectives of the fire safety design are defined. That tend to be drawn from the architectural requirements and the functionality of the building. The performance criteria are established and acceptance criteria are set. So that QDR is a very important part of the process. Then the next bit is the quantitative analysis. So that's where engineering methods, hard sums, maths, computational fluid dynamics, that kind of thing, go on to evaluate potential solutions. Then the important bit is assessing those outputs against criteria. That's the results of the quantitative analysis are then compared against the acceptance criteria to work out whether the solution is safe or otherwise. And that quantitative part is divided into a number of separate parts or subsystems. Each can be used in isolation, or They can be used in combination, and that's sort of represented on this difficult to read and unnecessarily complicated diagram, which you see above. Yeah, that shows how these different subsystems work together. The work of FSH24 is continuous. I go on about FSH24 quite a bit because I chair it, so I'm quite close to how things get developed there. The last part was written from scratch was in 2012. That was PD8, which is an interesting document because that describes a way of introducing those property protection and mission continuity objectives that we talked about at the beginning that are difficult to find sometimes. So it's an invaluable tool that really is used in discussions between architects and their clients about what they should be paying for up front, getting resilience in the design. And then, as part of BSI's 5-year review cycle, it was decided in 2016 that it was about time we revised the documents. So we got a panel of volunteers, experts together, and that revision process began. And after a period of hard work, through a draft that was published for public comment, the current standard was launched in 2019. I'll just quickly tell you what's different from the previous version. So the British standard itself has completely been rewritten. It now incorporates those recommendations that were previously in PD8. That's why that's shaded out now. PD0 has been withdrawn because it was largely duplicated. And PD4 has been withdrawn because it provided guidance on fire detection and activation of fire protection systems, but that guidance is that you can find it elsewhere in different standards. PD5 was amended rather than fundamentally revised, and it was amended to reflect changes in practice and advancements in knowledge. But importantly, it was amended to incorporate some of those emerging lessons that were coming from the Grenfell Tower public inquiry from phase 1 findings. Now we know that more findings are going to come when the public inquiry findings are released next year, so there'll be some more to do there. And that's where we are today. And I can tell you've done the maths and you know there's a 5-year cycle and it was 2019, and that's right, next year we're going to have to start that process again. So, I think it's generally agreed that traditional prescriptive design techniques have their place, but they can be a barrier or a stunt for innovation and creativity. And they're impossible to apply sensibly to particular buildings with special functions, such as entertainment venues, high-rise developments, sports stadia, airports. I mean, fire safety engineering has really freed up building design. It's facilitated it, whilst, because we've got that standardisation process in BS 7974, the process has provided suitable levels of safety when carried out properly. And fire engineering was originally the pioneering method of enabling the design of buildings such as airports and enclosed shopping centres, but such buildings are now commonplace. The new frontier for fire engineering includes the design of very tall buildings, such as those using lifts for rapid evacuation of occupants. And another area where fire engineering is beginning to impact concerns the sustainable construction agenda, helping to address that balance between protection of the environment and prudent use of natural resources. Now, despite these successes, research has revealed that concerns exist surrounding the use of fire engineering principles, and these include questions as to whether fire engineering design community has the knowledge, data and tools required to fully undertake these advanced analyses. Furthermore, motivations for using fire engineering are sometimes being questioned. Numerous examples are being documented where architects, I probably should say, and other building designers, are seen to be sort of trying to buy their way out of problems that they've created through poor design by using complex technology and inappropriate fire engineering arguments, perhaps. one article, as I read, describes this as performance-justified engineering and warns that fire engineering constitutes a significant threat to the credibility of it as a design tool. And similarly, there are concerns over the fire safety objectives used to compile a fire strategy. It's common practice for projects to concentrate solely on life safety, because that's that bit that's mandated by the building regulations, and it can have a detrimental effect on property business protection when compared with prescriptive solutions. And I'll talk about an example of that later. So, it's widely accepted that the profession has matured from its origins in the mid-80s to a situation today where it's emerged as a recognised separate engineering discipline. Fire engineering is becoming more accepted in the UK, and a change has been seen in the types of buildings that fire engineering is applied to, recognising that it's frequently applied to more mundane projects. There sometimes feels as though there's a proliferation of designs for buildings which don't comply with prescriptive codes that have been labelled as fire engineering, because it enables them to be put forward with an argument as to why they don't need to comply. And it's important that we use fire engineering correctly for the right reasons and for the right projects. Fire engineering has been able to be used more widely because the tools that are available are now more sophisticated. That's another indication of a maturing discipline. If you think about computing power needed to do CFD simulations and things like that, that's come on leaps and bounds now, so we can do more iterations of designs on desktop computers, where it might have taken several computers in a different room running overnight in some instances before. And I know we've got a wide variety of professionals here, fortunately most from perhaps the materials and mining sector, but I'm going to venture into a bit of controversy now, and I'm going to tell you a bit about some research I carried out a few years ago and the results that were published. It was a really interesting piece of research, and it involved me asking interviewees about the perception of the roles of other stakeholders that are involved in fire engineering. Analysis of their responses shows that interviewees had more critical comments to make about their fellow professionals. So this is why I tread carefully at this point. The 4 stakeholder groups that attracted most criticism were architects, regulations enforcers, sometimes known as building control, insurers, and practitioners, fire engineers themselves. So over the next few slides, there's a selection of sound bites. It's not the whole story, so don't shoot me, I'm just the messenger. So, whilst the input from academics is widely valued by their fellow professionals, it was felt that they're often disconnected or removed from the real world. This was felt both in terms of teaching and research, as their industrial experience is perceived to be limited, and they struggle to keep up with the speed of change. The work of building designers was described as mostly well-intentioned. However, they did receive quite a bit of criticism from other interviewees for not understanding fire safety issues and not understanding how to use fire engineers. There was an issue reported of architects losing skills. That was raised a few times, as well as many interviewees criticising what they considered to be inadequate fire safety-related training in architectural degrees. End users, so people who commission new buildings or use the buildings, end users, their criticism can be summed up as a lack of engagement when the building is designed, and then falling short of their responsibilities during the operation phase. It was stated that often end users don't even know that they're in a fire engineered building, because of the lack of information that's transferred to them through the construction company to the client. Enforcers, so there were some encouraging comments made about competency and actions of enforcement, both building control and fire authority based, but there were some critical statements made as well. There were many criticisms about the skill base within building control, don't know what to look for, don't know how to challenge. There was an agreement that enforcers need to be trained as well as, if not better than, the engineers in order to work in this performance-based environment. Bit of a conundrum there. Practitioners of fire engineering, those consultants, they received some criticism from their stakeholder colleagues. Comments range from criticising their perceived intentions to their working practices and the commercial pressures that practitioners often work under. This sounds a bit depressing, doesn't it? Insurers received a similar level of criticism. They've got an important role to play in building design. They're an important stakeholder. They have a financial stake in the success of the design, but their poor levels of knowledge and understanding really precludes any meaningful interaction. Manufacturers and installers of the building products that support fire strategies, sort of enable fire engineering, they're needed and they're welcomed. But one practitioner described them as creating an armoury of measures that you can deploy in designs. But it became clear that people have also experienced manufacturers who disregard fire safety when they're developing their building products. And on-site installation, workmanship is an issue that's identified quite commonly and quite critically. There's criticism levelled at the lack of supervision and checking on site as well. Right, I think we can brush over that one for now. Institutions and trade bodies are seen as vital within the fire engineering process. They're the groups who translate research into practice. Even the IFE received some criticism. It was thought they could do more to promote good practice, regulate its membership, things like that. And I'm pleased to think that since I did this research, great strides have been made and continue to be made, particularly following Grenfell Tower fire and the review of building regulations and fire safety that was carried out by Dame Judith Hackett. She really amplified all aspects that were highlighted in that this research revealed. And much support has been given to tackle some of these issues and make the environment that we work in as fire engineers better. So thinking about tomorrow and thinking about how fire engineering can be, whether our future building design challenges are squiggly or straight, whether they're even floating, whether our challenges are for our buildings are green or even golden. Really, fire engineering uses established methodologies such as that outlined in BS 7974 as a key process for facilitating such design freedoms whilst giving a robust methodology to ensure adequate levels of safety and resilience provided. Now I'm checking the time, and I know I'm okay, because I'm now going to explore the thorny issue of competence for the fire engineer. And I'm going to be a bit selfish because I'm quite interested in the history and how our institution developed and how the profession started. So I'm going to take a quick look back at some of the discussions that were had about competence in the past. So I'm going to revisit some of those light bulb moments because it's very interesting to see that there's nothing new in this. People have been saying it for a long time and we just seem to forget. So I'm going to begin with some wise words from one of the pioneers of fire engineering, and I've already mentioned her because she was influential in the design of Stansted Airport, and this is Margaret Law. And Professor Law began her career as a scientist at the Fire Research Station, and she carried out research into many aspects of fire behaviour and its effects on building materials and structures. And she became involved in the application of these research results into building regulations, into codes of practice and into design guides. And she joined Arup to act as an advisor on fire engineering for those projects that they were designing. Now Margaret's scientific work and her fire engineering work continues to be very influential. She believed profoundly in what she termed measurement, and that's a belief that drove her work, was always founded on quantified scientific criteria and always rigorously derived. So I just want to spend a few moments reflecting on Margaret's thoughts when she was answering a question, what is a fire engineer, in 1990 in a conference paper, because her answer is interesting. She boils it down to 6 characteristics. So she says, whatever their speciality, engineers have certain assumptions and background knowledge in common. They can discuss concepts across the frontiers of their speciality. The concept of flow, for example, whether it's water down a pipe, people down a corridor, electrical charges and so on, these can be discussed directly or by analogy with ease. Physical and mechanical behaviour of materials and structures can be understood and discussed in a broad way. Engineers, by their education and training, have these concepts built into them and discuss matters accordingly. So here, Margaret is she's describing fundamental engineering education as a prerequisite. Measurement and quantification are fundamental to any proper engineering design. She says, it is sad that so many people are reluctant to measure things. Presumably, this might cast doubt on what they know to be right. Because fire danger and the effects of fire can generate deep emotions, the proposal to reduce such matters to cold numbers seems to be callous and not a proper response to the imponderable forces of nature. Yet decisions have to be made, she goes on. So my second point, therefore, is that a fire engineer must understand how to measure and quantify fire phenomena and fire safety. So Margaret's emphasising that fire engineers must be able to apply those prerequisite engineering principles to the fire phenomena, and that quantification is an important way of making comparisons and making decisions. She says, fire engineering is an important component of most activities and no one person could hope to be an expert across the board. Nevertheless, the fire engineer should have an awareness of the various aspects and an ability to identify potential problem areas and where to go to find the answer. So I think this is quite self-explanatory. She's saying fire engineering is a broad subject area. As fire engineers, we must be as aware of much of it as we can, but recognise that we're not expert in all of it. Experience as well as academic training is recognised as an essential part of engineering training and is just as important for fire engineers, she says. So, obvious, isn't it? The fire engineer should have the opportunity to gain practical experience. The next one, she says, over the career of a fire engineer, there will be many changes in technology, lifestyle, knowledge, which need to be recognised and understood. For many aspects of fire safety, there is not yet the basis of engineering design approach or enough accumulated practice on which a code of practice can be based. Therefore, it's particularly important that the fire engineer keeps ahead of the latest research and developments. That's CPD, isn't it? That's what she's describing. Finally, she said, the fire engineer needs a certain toughness, and I'm referring to intellectual toughness. By this, I mean the engineer must be able to be tested and challenged and deal with matters in a rigorous, analytical, and above all, honest way. The fire engineer must be tough enough to stand up to a good deal of questioning and in turn be able to push other people in the same way. Justify what you are saying if you want to be taken seriously. So with this lecture, Margaret spells out what she sees as being the important attributes of a fire engineer. And I think we can all recognise she's talking about competence. Competent is knowledge, experience and behaviours. She finishes off that lecture by saying, what makes this list different from other aspects of engineering? Nothing. Only that with fire safety engineering, we've got to spell it out. It's not yet taken for granted. So I think it's worth having a look back to 1990. I think that was priceless. So I'm going to swiftly move on to some principles. And when I talk principles, I want to highlight principles that were set out in the work of Mostyn Bullock, Neil Butterworth and Adam Monaghan back in 2004. They developed a series of articles which we published in our journal. And if you have access to institution journals, then I'd seriously recommend having a look at these articles because they were born out of the work of the Institution of Fire Engineers Special Interest Group on competency and ethics. And in that first paper, The Development of Competency in Fire Engineering, Mostyn and Adam describe how and when the Institution of Fire Engineers gained its Engineering Council licence and began registration activities in 1997. So this is the Engineering Council's mission statement, and it refers twice to competence, and that's no accident. So the paper reads, "The timing was right. Design and construction in the built environment was in a period of significant change and relative well-being. Many large-scale projects were underway or in the pipeline where design requirements demanded significant freedoms from hitherto closely prescriptive approaches. The fire engineering profession flourished and prospered in this environment. The time when fire engineering was principally the reserve of academics and scientists and insurance surveyors had passed. The rigorous process carried out by professional engineering institutions are designed to deliver the demanded standard of competency. Registered fire engineers are bound to work under a code of conduct of both the IFE as a condition of membership and of the Engineering Council as a condition of registration." So who can argue with the sense of that? It would therefore seem obvious to expect practicing fire engineers are competent. Well, wouldn't it? The paper continues, "The profession can do all it can to produce fire engineers to the highest calibre, but the domain in which these engineers operate presents serious challenges to competent and ethical practice that just can't be ignored. This domain isn't just about the technical nuts and bolts of fire. Rather, it is those aspects of professional conduct which relate more to ethical practice in fire engineering and project management." So they're seeing that it's very difficult working in this sphere because there are lots of competing pressures on the professional and lots of commercial pressures as well. It's also crucial to recognise the thing that sets fire engineering apart from the majority of other engineering disciplines in the built environment is that fire is an accidental loading condition, i.e. there's a significant probabilistic aspect to its application, whereas other areas of design, such as structural, acoustic or thermal performance, are all normal day-to-day service conditions. So we've got to be honest with ourselves and acknowledge that this can lead to an apathetic approach to fire safety. You know, fingers crossed it won't happen to us kind of thing. Or the perceived need to engage a competent fire safety professional being given second billing in comparison to more pressing concerns. So that was in that paper, and it's gripping stuff. It's also relevant. It's relevant today. I've gone and done that problem again of fiddling with the mouse, and it's. I think I've sorted it. Thank you. So Neil presented a summary of this work in a conference. His presentation, he talked about the Engineering Council's UK spec objective about ethics. It's a statement of ethical principles, sets a standard to which members of the engineering profession should aspire in their working habits and relationships. It talks about values on which they should be based. And Neil highlighted fundamental principles that run through 4 pillars of that statement. And these are the 4 pillars: accuracy and rigour, honesty and integrity, respect for life, law and the public good, and responsible leadership. So what Neil was doing was setting out ethical behaviour as an integral part of competence and essential in achieving competent fire engineering. And I'm pleased to say that that set the foundations for strengthening the IFE's code of conduct for members and registrants, and we formed a whistleblowing policy and guidance and the establishment of an ethics committee. I'm also pleased that building on this, I've just realised that these slides aren't going forward on the screen. Sorry.
I'll have to kill it again. And we'll start from. Actually, can you put me down the number?
Yeah.
That's the orders.
Yes, it's around here, yeah. think so. This is going to present some interesting editing for you.
Yes.
Yes, thank you. Yeah. Yeah, sorry. Again, it's not changing the notes on the bottom, it's just what's on the screen. So that slide is not associated with that, yeah.
Let's pull this up before we start doing anything. Let's come on to slide 59. Slide should hopefully current slide.
So let's change that, but not that.
Try again.
So now that's changing that, but it's not changing that. And if I click that, yeah, so it goes on, but not to that.
Okay. I think we're going to do it for a bit. Should we look at that first? I think that's unfortunately going to have to be, as you say, have to edit this bit out. I'll have to play in this.
We're going to have to see Donald Trump again, aren't we?
Yes. We'll skip over them quickly. So I think you're close to it there. aren't you?
Yes. Fantastic.
Sorry about that.
Thank you very much. Yes, so we've just been through these 4 pillars, and I was just saying how this led to the enhancement of IFE's whistleblowing policy and establishment of an ethics committee. And the Engineering Council and the Royal Academy of Engineering built on their Statement of Ethical Principles that was established in 2019. The group published a report called, you can read it, Engineering Ethics, Maintaining Society's Trust in the Engineering Profession. It proposes actions and appropriate regulation to achieve more ethical culture in UK's engineering profession. It reminds us of the inevitability that there are tensions between profitability, sustainability and safety that engineers seek to be aware of and need to balance. And there have been some important questions posed in recent years, and social media has amplified that public scrutiny. This report cites the work of Dame Judith Hackett, who carried out her review of the building regulations and fire safety following the Grenfell Tower tragedy. And she highlighted that it was a cultural issue across the construction sector, which can be described as a race to the bottom, caused either through ignorance, indifference, or because the system does not facilitate good practice. This is my final person I want to talk about who gives some important information about competence. Dr. Angus Law, he's a lecturer in fire safety engineering at the University of Edinburgh, and he's a member of IFE, and he was asked to chair a meeting on competence in June 2018 by the industry response group, which was set up following the Grenfell Tower fire. I love a good quotation, and Angus quoted Confucius, "Real knowledge is to know the extent of one's ignorance." And he also cited work by Kruger and Dunning from 1999. Are you confident because you have knowledge, or are you confident because you have no knowledge? And the purpose of this aside was to make the point that one of the most important aspects of competence is assessment of self-competence. But also there's an inherent difficulty in that, because the lack of competence can give an illusion of competence, and often those with the least competence consider themselves most competent. Bit of a conundrum. But Angus introduced the concepts of specific competence, common competence, and interdependencies. So specific competence, so particular professions will have specific competencies that only that profession can have and only that profession can assess. For example, specific fire engineering skills. Common competencies are those across professions, and professional ethics sort of sit in that type. And then there are interdependencies, so competencies required of one profession by another profession. And he also said that a professional institution, by definition, should have a monopoly on a given activity. For example, a fire engineer can only be assessed by a fire engineer. And this work was summarised in a report that was submitted to Dame Judith as part of her review, and set out 3 principles, which was the kickstart. So, I'm not going to read these principles. The core set of principles and expectation and assessment. That was a kickstart for work which has led to another BSI document I'm going to tell you about, which is called Flex 8670. And this is core criteria for building safety in competence framework. It's a code of practice. It was published in April 2021, and it was created in response to findings from the Hackett Review, which highlighted a fragmented approach and a lack of consistency in the processes and standards for assuring competence of those working on buildings as a major flaw in the current system. So Flex 8670 provides a core set of principles of competence, including leading and managing safety, communicating safety, delivering safety, risk management, regulations, processes, building systems, ethics, and fire and life safety. Whatever the profession, everyone should have an understanding of some aspects of fire and life safety. So, what's the common theme with Margaret Law, the principles outlined so well by Mostyn, Adam and Neil, and the work from Angus Law, and the Royal Academy of Engineering's work, and Flex 8670? Well, I see it as this. Amongst other things, being competent is a combination of acquiring knowledge and practicing experience. And we now know living by appropriate behaviours. And I think as an institution and as a profession, we've known this for some time. And for me, the important element of this is the behavioural aspect. I think it's about taking personal responsibility. I think competence is something that it isn't something you can expect your professional body to do to you. You've got to live it, you've got to show it, and importantly, if you're acting as a professional, you've got to be able to demonstrate it. I'm conscious of time, but I've had a few interruptions. Can I carry on? So I'm pleased that in response to another proposal from Dame Judith Hackett in her independent review, the Engineering Council has developed and has now published a version of their UK standard for professional engineering competence and commitment, the UK spec as we know it, contextualised for higher risk buildings, so those types of buildings, that type of building that Grenfell Tower was. And UK spec HRB is a new standard from the Engineering Council that sets out competencies and commitments expected of engineers and technicians who work in the built environment sector, in particular on higher risk buildings. So it's been contextualised for engineers and technicians who are involved in building work, including design, construction, maintenance and operation. It incorporates that core criteria from that Flex document I was talking about and sets it out in a way so that PEIs, professional engineering institutions, can assess their registrants against this. And the Institution of Fire Engineers is licensed to register professional engineers against the fire discipline annex of this document, UK Spec HRB, and we'll be launching that in the new year. So, I'll be mentioning the Institution of Fire Engineers, but what is the Institution of Fire Engineers? Who are we? Well, we were founded in 1918 in a fire station in Leicester by 6 chief fire officers in a time when medals and shiny helmets was impressive moustaches was a thing. And in more than a century since, we've grown into a truly global organisation, uniting all fire professionals. Our members share a commitment to fire safety, and the fire profession remains valued and relevant, protecting people, property and the environment from fire. And these are the objects that were set out in our founding Memorandum of Association back in 1918. So we were founded to promote, encourage and improve the science and practice of fire extinction, fire prevention and fire engineering, and all operations and expedients connected therewith, to give an impulse to ideas likely to be useful in connection with or in relation to such science and practice to the member of the institution and to the community at large. So just as relevant today. We have members representing the whole spectrum of the fire sector. I've said we're a professional engineering institution, so we're licensed by the Engineering Council to register chartered engineers, incorporated engineers or engineering technicians. And we operate a UK-based fire risk assessor register. And there are some statistics here, 11,000 members worldwide, lots of branches, lots of exams, lots of registrants. I'm on the home stretch now. So, why is what we do still relevant? Here's the obligatory photo that precedes most building safety presentations these days. I appreciate it's now 6.5 years ago, but we can all reflect that June 2017 in West London there was a tragic fire that claimed the lives of 72 people in their homes. Since then there's been numerous reviews, we've talked about them, most notably from Dame Judith Hackett. There's been a public inquiry that's still in process, not yet fully concluded or reported, and then criminal investigations will follow, as well as a whole lot of soul searching. But fire is still using its destructive force. Let's just think about the last 6 months. At the end of August this year, 74 people died following a fire in Johannesburg, South Africa. So dozens more were injured in a blaze that happened in a 5-storey building in Marshalltown, Johannesburg. The building had been abandoned at one stage, and then people had been living in it. It's an ageing building, located in a deprived area. It used to be the business district in Johannesburg's economic hub. It was being used as an informal settlement. And this area is infamous for what's called hijacked buildings. And that's a term used in South Africa to refer to buildings that have been illegally taken over by unscrupulous landlords who rent them out. So there were shack-like structures were constructed inside this building. And there was a gate that was locked, and many of the dead were found trapped against this gate. Now, this is an extreme case of inappropriate change of use, and I'm not suggesting that as designers and engineers we can be mitigating for all kinds of things like hijacked building scenario, but it's an interesting event that really we need to be aware of and think about, I feel. Fire swept through a Christian wedding party in northern Iraq towards the end of September this year. It killed 107 people. So fire ripped through Al Hatem Hall. It's a large event venue located on the outskirts of a northern town, Karakosh. And fireworks were lit inside the building as the bride and groom danced. So the head of the investigative committee, General Syed Fowler, said that 4 pyrotechnic devices shot showers of sparks 4 meters into the air. And this was the distance that allowed them to reach the hall ceiling, ultimately leading to the fire. It was also said that the hall had a capacity of 500 people, and twice that number were in the building when the blaze started. In October, the 1st of October this year, a fire broke out, this is closer to home, in a building hosting 3 nightclubs in Murcia, in Spain. 3 people were killed and 24 injured. the deadliest nightclub fire in Spain since 1990. Now, the building was split into 3 different venues, and the fire broke out on the first floor in the Fonda Milagros club, and then it spread to the adjoining Theatre and then Golden nightclubs. So authorities attributed the rapid spread of fire to the air conditioning system, which served all 3 buildings. And also, the fire was so intense that there was some substantial structural damage. So 13 people reported to have died in the fire and 24 injured, at least 4 of them hospitalised for smoke inhalation. So why are these events important, the one in Iraq and the one in Spain? Well, they clearly combine issues of building management along with regulation. But there are design issues worthy of note, the provision of escape routes, understanding the anticipated numbers of people who are going to inhabit the buildings, consideration of materials used for internal linings, separation of buildings, protection of building services that go through them. I think I've done it again, you know. But we're very close now. Yeah, fantastic. Thank you very much. I'll only touch this.
I'm not going to leave it out next time. Slide, front cover slide.
Thank you.
No.
So if I do that, no. Yes, that has. Right, so this is a little different, but 2023 was an incredible year for wildfires, particularly in parts of the world that are not used to suffering them. During July this year, multiple wildfires started in Greece and resulted in at least 28 deaths, with over 80 wildfires recorded in that one country.
I'm sorry.
Thank you. So this is a little different. No. So in Canada, almost 25,000 people were evacuated from their homes due to wildfires.
Sorry. Apologies, gentlemen, ladies. System out. I overran by half an hour on a talk, so you're still okay.
Oh, I've got plenty of time then. Brilliant. Thank you. Thank you. Almost 25,000 people evacuated from their homes due to wildfires in Canada. More than 10 million acres of land became involved, the country's worst wildfire season ever. And the wildfires in Canada this June caused huge air pollution problems in New York, Washington, and Philadelphia. So why are these worthy of note? Well, There are areas in the world that are categorised as wildfire prone, such as many areas in Australia. They call them bushfires. And architects and engineers are well aware of how urban planning and building design has to be mindful and prepared for this in that wildland-urban interface. But these wildfires are happening in different places now, and I think as responsible designers and engineers, it might be necessary for us to start to remember those lessons that have been learned in other parts of the world, maybe worthy of closer inspection in areas that are less familiar with it. For example, here's a particularly swanky version of a bush fire resilient house in Australia. That's designed specifically to resist wildfires progressing over it. Probably a bit extreme for the UK, but let's not forget wildfires are occurring more frequently even in the UK. This May, the largest recorded in the UK. Scottish Fire and Rescue Service said flames had burned through a 30 square mile area of scrub, and a 12-mile plume of smoke from the incident was detected from space by NASA satellites. So they're coming to the UK. Now, this is closer to my home in South Leicester. An industrial premises suffered a large fire back in June. That smoke could be seen from miles away. And this is what was left. All that remains is for the site to be demolished. And the company itself had a good disaster recovery plan with alternative sites in different areas of the country. But the fire has led to the closure of the site in Leicester, and it will result in job losses. And it reminds me of a fire closer to where we are today. If you remember in 2019, the Findus factory in Long Benton. You remember it, don't you? You remember road signs used to say, "Welcome to North Tyneside, home of the crispy pancake." Well, that just reflects how important the factory was to the local economy and the community. The factory didn't reopen. Let's end with another corker. In October, there was this fire in a car park at Luton Airport. It started about 9 p.m. on Tuesday the 10th of October, and it was extinguished by 9:30 the next day. But the airport was closed until 3 p.m, so that's 18 hours the airport was closed. So the consequential losses of closing an airport for 18 hours run into hundreds of millions. The fire appeared to have been accidental, began in a parked car, a diesel vehicle, and the fire caused part of it, this recently finished multi-storey car park, to collapse. At the peak of the fire, Bedfordshire Fire and Rescue Service had 15 fire engines there, 3 specialist aerial appliances, more than 100 firefighters. This is what was left. The airport said any cars parked on levels ground to 3 are not recoverable. Now, and the car park has to be fully demolished. Now, this means that the airport will be without their main car park for a considerable amount of time while this is demolished, the site cleared, and something built in its place. And why am I telling you this? Well, we were talking about fire safety objectives, and we understand that life safety objectives were met. This fire illustrates that. Some firefighters sustained some smoke damage, but no lives were lost in this fire. But we're not thinking about resilience here, are we? This fire perhaps illustrates a bit of short-sightedness in not thinking about that, not installing sprinkler protection, and the result could be very different. And another frustration is, as an industry, we know about this. This was the Liverpool Echo Arena fire that happened in December 2017. Very similar, well publicised. It happened before the Luton Airport car park was even conceived. So architects and other principal designers, they're ideally placed to help their clients make the right choice when it comes to investing in resilience. And we all have a duty to remember and learn from things, from learning from the past. Okay. Apologies for the technical interruptions. I know we've covered a lot in this lecture. We've taken a look at the origins of fire engineering, described its development, how it became standardised in a code of practice. I've introduced the Institution of Fire Engineers to you, and we've considered some of those competence questions that are critically important, as well as consider some fires that have just happened over the last 6 months. I hope it's been of interest, and I also hope it's perhaps the start of an ongoing relationship between the Mining Institute and the IFE, because it would be great for us to come together more often, especially those of our members that are based in the northeast. So thank you again, and happy to take any questions.
Well, thank you very much indeed, Peter. I hope you'll take this as a compliment, but I can see the way that you're working on the Institute of Fire Engineers was very much the way we had to start in 1852 with the Institute of Mining.
Sure.
We had the same sort of problems. We had to learn from what was happening, which you are continuing to do in a very, very modern environment. So for that,
Good parallel.
I thank you very much indeed. Right, do we have any questions? Right, Norman Jackson.
Norman Jackson from Seasource. Thank you for that talk. Very, very interesting indeed.
Thank you.
One thing that concerns me is high-rise buildings. And you mentioned that the first thing that happens if you do have a fire, they tell you not to go to the lift.
Mm-hmm.
Now, in a 30 or 40-storey building, if you're an old person, there is no effective way out. I understand the design which compartmentalises it, where the fire shouldn't spread, but inevitably it does. And it's just my thoughts on when I go to a hotel now, I never go above the 4th floor. I always tell them I won't go any higher,
Right.
because that's the length of most ladders. So really just your comments on that. These buildings are getting taller and taller. What is the second means of egress?
Well, thank you for coming in with a really interesting question, which lots of questions involved in that. So for ultra tall buildings, there are several around the world where you do actually use the lifts in an evacuation situation. So the lifts are protected, they have alternative means of power, they have adequate separation, physical fire separation from different parts of the building to enable them to be used in an evacuation. But the interesting thing about that is changing the mindset of building users, because it's, as you say, it's always been drilled into us, when the alarm goes off, do not use the lifts. So there are some special types of buildings where lifts can be used. And you also mentioned that it's also quite a politically loaded question. You asked about having alternative means of escape or a second staircase within buildings. Now, if you're in a high-rise building that has been designed specifically for, such as a block of flats, that the tried and tested strategy for that may only require one staircase, because the fire strategy, the fire principles are that you would remain within your own apartment or your own flat. That is the safest place to be, and it's a fact that there were dozens of fires at Grenfell Tower before it was reclad, and they were all dealt with within the flat of origin, or within the room of origin, and other people within the block of flats didn't even need to know about it. What went wrong there was a catalogue of things, and probably the most prominent one was the cladding on the outside. But yes, you may have seen that there is a new requirement for new high-rise residential buildings to have a second staircase incorporated within their design. But I say that's probably a socio-political kind of motivation to have that. It might not be the technical or science argument behind it, but in some situations, having a second staircase is absolutely the right thing to do. Difficult to retrofit them to buildings that have only got one staircase, and it probably wouldn't be sensible in those situations. So I think clever people in government, are working on some transitional arrangements for how that new legislation might come in and apply to existing buildings as well. Yeah, that was a corker, thank you.
David Granger, Sunderland. Thank you for the talk, it was very interesting. When I was a child, I lived on a housing estate, a council estate, and it's quite regular to have chimney fires because everyone had a coal fire. Yes, you had, if you were sensible, you had your chimney swept, however often needed to be. But some people actually, well, can't afford to pay for the chimney sweep. I just let the fire go and burn all the sorting out of the chimney.
It's a risky strategy, that one.
Good practice. But Norman touched on I was going to jump in and talk about high-rise building. I've recently been to Dubai, and of course Burj Khalifa is that spire that goes up into the air, tallest building in the world. You said that I would hope that the lifts in that building are fireproof so that people who live on the top can get out. Do you know anything about that?
I don't know anything about that design itself, but it could also have a strategy where every 10th floor is designated as a safe floor that if you evacuate to a particular place within the building, so a place of relative safety rather than ultimate safety outside of the building, and that's been designed so that it is protected, that it can be resistant for a long period of time. So you get to that, you make your way to that place, and then further evacuation can take place over a longer time period if necessary. But yeah, interesting that you're talking about chimney fires. I find it fascinating. Sometimes I go and visit Fire and Rescue Service colleagues, and it's interesting how their training has to develop now, and they have to train on simulators for putting out chimney fires because they're now so infrequent that they don't see them every day. So they're unusual things to have to deal with. And same with chip pan fires, because we don't fry chips in chip pans these days. And thank you for reminding that.
Do we have any other questions from the floor? Let's say no. Dave, have we got anything online? No, it appears not. Well, there we are. You answered those questions very, very well, Peter. Thank you very, very much indeed.
Brilliant.
So now we're in the situation. Could I call on Mr. Norman Jackson, please, to give a vote of thanks?
Where mining engineers, the word fire is a horrendous thing in our book, and indeed over the centuries we've been learning to manage fire in a different way.
Sure.
We have had so much innovation, starting with the changing from candles to the flame-faced safety lamp, right away through all the gambits that have been developed within our engineers. There's an engineer sitting not far from me who, one of the things we feared was methane explosions. And of course the design of that was designed out to reduce the risk by injecting water right to the pick point where the coal was being cut. So that we've gone through huge changes in the mining industry to manage the risks from fire. Because when you're looking at, particularly in the northeast where the mine workings were sometimes 10 miles out underneath the sea, you had to be very, very competent. Competency with the engineers that were designing the mines, make sure that we didn't have more than 2% of methane in the airflow. All of these had to be properly managed and designed. And I think this institute would, of course, welcome further cooperation between the Institute of Fire Engineers and ourselves. There's a lot in common. I'm sure each person could learn from the other. But thank you again for giving up your time and travelling up here to give us this talk.
Thank you.
I would like the members and those present to show their appreciation in the normal manner.
Well, there we are. Thank you very much once again. Just may I give a few closing remarks, some of which to remind you, of course, to sign on the registers. The next one would be, let's have a look. Where are we? Yes. That more or less to remind you that we are having another lecture in January, the 18th, which will be the launching event for Les Turnbull's next book, The Wilkinson Railway, which is quite an interesting one because he's more or less telling us more about railways before 1825, when we thought the Stockton and Darlington Railway and the rest of the world thinks the Stockton and Darlington Railway was the be-all and end-all of everything. When in fact, with Les Turnbull's research, we are going to find out that there were people quite a few years before that who were very, very competent in doing, a major job in developing railways in the northeast. So that would be on January the 18th. On February the 15th, we have a joint lecture with the Institute of Corrosion, and we have spoken with them, or we've had lectures from them before. Incidentally, there was one thing you were talking about, within fire safety and such like. We did have a lecture some while ago about protection coatings for steel and such like, which I think we all found very interesting too. And, it just shows so much is going ahead with this sort of thing. And it's developing very, very fast, I think. So there we are. So thank you very, very much for coming along. Please remember that if you want to support the Institute, the IOM3, please go ahead. All the details are there. And remember, if you want to become a member of the North of England Institute for Mining and Mechanical Engineers, to do so, we have all the documentation available online on our website, which is worth a look anyway, because there's a lot of detail on that website that I'm sure you'll all enjoy. So once again, thank you very much for coming along this evening, and thank you very much for everybody who's on Zoom, and we've all enjoyed our evening very, very much. Thank you, Peter.